Let's talk a little bit about multi-zone heat pumps, sizing, and efficiency. I got to say, the first time I ever thought about this was when I saw a study published probably 10 years ago now, maybe 2015 in that time frame. Here's one chart of the results. This shows efficiency on the y-axis. This is COP, heating COP at 20 degrees when it's 20 degrees outside. And on the x-axis, these are one-to-one systems. So for all the one-to-one systems they monitored in this study, there were hundreds of systems. Most of them were one-to-one. The average COP when it was 20 degrees outside was about 2.2. Two-zone systems, 2-to-1 systems, the average COP when it was 20 degrees out was 1.8-ish. And there were also a few 3-zone systems. The average COP was maybe 1.3, 1.4 for these systems. And this absolutely baffled me. I did not understand why this trend of less efficient multi-zone systems happened. But I did talk to quite a few others, including many contractors, and this seemed to be pretty well understood that yes, multi-zone systems were less efficient than single-zone systems. One other study I wanted to mention, this is more recent. This was in, that previous study was in Massachusetts and Rhode Island. This was in New York primarily, if not exclusively. And these were systems that were pretty carefully designed by engineers and contractors in conjunction with the manufacturers and distributors, really thoughtful designs that were then monitored. The performance were monitored. There were 20 one-to-one systems in this study, and they found this is seasonal COP, was above 3. So on average, these 20 systems had a seasonal COP of 3.2-ish, which is fantastic. If you can get COPs above 3, that's wonderful. There were 15 two-zone systems, 2-to-1 systems. Considerably lower COP, 2.2 instead of 3.2 for the 2-to-1 systems. There were also several 3-to-1 systems. These were a little higher, 2.5. 4-to-1 systems, 4-zone systems, COPs barely above 1. And there were also 3 5-zone systems, and the COPs were up at 1.5. So we don't here have a nice straight line showing the decline, but the trend holds true. Multi-zone systems often are less efficient. And I think there are a few reasons why this is, but I think sizing may be the predominant reason why this is. And multi-zone systems are very often oversized. In some cases, it can be hard not to oversize multi-zone systems, and I'll walk through some examples here. Well, actually, not even a real-world example. I have many real-world examples of multi-zone systems that go wrong, but again, I don't want to throw anybody under the bus. So this is a pretend house. This is a theoretical, small, fairly efficient home in a coldish climate, and say that there are 5 different spaces, rooms or spaces in the home, and these are the loads for those spaces. If you add them all up, total design heating load, 20,000 BTUs an hour. And now I'm going to read some advice from a manufacturer application note. And this may be boring you think it's boring to hear somebody read out notes from an application note, but this is incredibly important. This is manufacturer advice on where and how to apply multi-zone heat pumps. The outdoor unit should not be selected based on how many indoor units are desired. If the outdoor unit is oversized just to provide a certain number of indoor units, overheating, humidity issues, and higher than expected energy usage can occur. I have seen all of these issues happen in oversized multi-zone heat pumps. Similarly, in the same application note, if an indoor unit, the previous slide was about outdoor units, this is if the indoor unit nominal capacity is more than 50% higher than the maximum heating or cooling load in a space, humidity, overheating, and higher than expected system energy usage can occur. So let's go back to look at this pretend example home. 5 zones, 5 rooms. The total design load is 20,000 BTUs an hour for this house. If you wanted a 5-zone heat pump, 20,000 BTUs an hour, it's probably a 1.5 or a 2-ton heat pump would meet the design heating load. In my experience, to my knowledge, you cannot get a 1.5 or 2-ton heat pump with 5 zones. That doesn't exist at this point in time on the market, and there are reasons for that. If you wanted 5 zones, you might have to go up to 3.5 ton heat pump, which is almost twice the capacity that you need in an outdoor unit just to get the number of zones. And per that note, that first note, oversizing the outdoor unit just to get more zones leads to problems. Poor efficiency, poor comfort. It's to be avoided. And look at it on the indoor units. Some of these say bedrooms upstairs, design loads of 3,000 BTUs an hour. That same application note said not to put in a ductless head with a nominal capacity that's more than 50% of what the design load is. So 50% more than 3,000 is 4,500. It is rare that you can find ductless heads with capacities of down at 4,000 or 4,500 BTUs an hour. They exist in a few applications and a few product lines, but often you're going with 6, 7, even 9,000 BTUs an hour as the smallest capacity for ductless heads that you might put in a room. So it's very likely that the smallest ductless head is going to be much, much higher capacity than the design loads in most of these spaces. There again, that is to be avoided. I've had one representative from the same manufacturer who published that application note tell me multi-zone heat pumps don't belong in high performance homes. If you have low loads, multi-zone heat pumps are not a good solution because they're just not well matched. There's certainly some homes where they are a good match, and I'm not saying avoid them always. When I'm designing a system, I start thinking about single zone, if I can get single zone to work, and then if I can't get single zone to work, or if it's practical to move into multi-zone, I certainly do that in some applications. And there are applications where it just makes sense, where it's, you just don't have enough room for the outdoor units, or there are applications where multi-zone systems absolutely make sense, but it's not where I start. I've seen a lot of contractors, big multi-zone systems, putting a head in every room as just the default design strategy. And I think that there's room for improvement there. I think if you simplify systems, put smaller, simpler, lower capacity systems in that can lower the upfront cost and improve also operating costs, lower the operating costs by being more efficient. We'll talk more about that in the next videos. Strategies to combine simpler systems with auxiliary heat, so different forms of resistance, to see how that works, how that can improve efficiency, cost effectiveness, and comfort. So the one takeaway from this, oversized multi-zone systems can be very inefficient. Pay attention when you're designing multi-zone systems, matching the loads, and really try to avoid oversizing them.